Hi guys, this is your channel Stat and Math Tutorials in a new video. Today I'm going to show you how to do the dot product of vectors. Then I will explain how to use this expression to find the angle between two vectors. So let's start. So first, the definition of dot product. So definition here. So the dot product of vector u equals ABC and v equals DEF. So the dot product of u v or u dot v, it's AD. So the first entry times the first, so AD plus BE plus CF. So that's how you do a dot product of vectors in 3D, in 3 dimensions. And it's similar to any dimensions. So let's do this example here. So the first vector -1, 2, 0. Second vector is 3, 1, 2. So let's apply the definition and do the dot product of these two vectors. So we start with -1 times 3 plus 2 times 1 plus 0 times 2. So we get -3 plus 2 plus 0, which is -1. So make arrows here. Okay. So the dot product of these two vectors is -1. So let's do another example. And this time the two vectors are given in the standard form. Now let's move this up. Okay. So u equals I plus j plus k, and v is 3g minus k. So let's change it to the form we had before. So u equals, so just do the leading coefficient of I, j, k. So the leading coefficient of I is 1, so 1, 1, and 1. And v, we don't have I, so go with 0. J is 3, k is -1. Now let's do the dot product of these two vectors. 1, 1, 1 dot 0, 3, -1. So the definition, same thing. 1 times 0 plus 1 times 3 plus 1 times -1. That's right. 1 times -1. We get here 0 plus 3 minus 1, which is +2. And the dot product, as I mentioned before, it's similar. Doesn't matter what you have, 3D or 2D, is the same way. So now suppose we have these two vectors in 2 dimension, 2D. So negative 4, 7 and 3, 1. So same thing, we just multiply negative 4 by 3 and 7 by 1 and add them up. Negative 4 times 3 plus 7 times 1, we get negative 12 plus 7 equals to negative 5. So now let's see how we can tell if two vectors are perpendicular to each other or orthogonal just from their dot product. So let me move this up. And go over this definition here. So two vectors are orthogonal or perpendicular if and only if their dot product equal to 0. So if I have two vectors u and v, this is u, this is v, and they are perpendicular to each other, so the angle between these two vectors is 90 degrees. So when you do the dot product of u dot v, you get 0. So to prove that two vectors are perpendicular to each other, you just need to prove that their dot product is equal to 0. So let's look at this example here. U equals 3 negative to 1 and v equals 0 to 4. So u times v, not times, but u dot v equals, so 3 times 0 plus negative 2 times 2 negative 2 times 2 plus 1 times 4. We get 0 minus 4 plus 4 equals 0. Therefore, these two vectors are perpendicular to each other. Let's look at the unit vectors in 3D, u and v. So u it's 1 0 0 and v is 0 1 0. So let's do their dot product. U dot v equals 1 times 0 plus 0 times 1 plus 0 times 0, and you see all of them equals to 0, so their sum is also 0. So these two unit vectors in 3D are perpendicular, and we know from the x, y, z coordinate that they are perpendicular to each other. So this is x, y, and z. In this case 1 0 0, it's this guy here, this vector, it's u, and 0 1 0, it's this vector here, v, and they are perpendicular to each other here in 3D. So now let's do another property of dot product, which is how you can find the angle between two vectors using this expression. Let me move this up. And first of all, we're gonna start with the formula. So the angle between two non-zero vectors, u and v. So let's see, I have these two vectors u and v. Sometimes we write a vector as arrow on the top of it. So, and the angle here is theta between u and v. So theta equals cosine inverse of u dot v divided by the length or the magnitude of u times the magnitude of v. And let me remind you how to find the magnitude of a unit. So let's see, I have not a unit but the magnitude of a vector, sorry. So let's see, if I have a vector u equals a, b, c. So the magnitude of u is the square root of a squared plus b squared plus c squared. So this is the formula to find the magnitude of a given vector. And let's see, we go over this example so we can better understand in this formula and how we can use it to find the angle between two vectors. U equals 1, negative 2, negative 2, and V equals 3 to 5. So we need to find the angle between U and V. So U it's 1, negative 2, negative 2, and V equals 3 to 5. Okay, so let me write down the formula again. So theta, which is this, the angle between, equals cosine inverse of u dot v divided by the magnitude of u times the magnitude of v. And let's find these things each one at a time. So let's do first u dot v. So u dot v, we said 1, negative 2, negative 2, dot 3, 2, 5. It will be 1 times 3, which is 3, negative 2 times 2, which is negative 4, and negative 2 times 5, which is negative 10. So we have negative 1 minus 10, it's negative 11. Okay, let's find the magnitude of u. So the magnitude of u equals the square root of 1 squared plus negative 2 squared plus negative 2 squared equals, so we have square root of 1 plus 4, it's 5, plus 4 is 9, so it's square root of 9, which is 3. Now let's find the magnitude of v. So the magnitude of v equals square root of 3 squared plus 2 squared plus 5 squared. We get the square root of 9 plus 4 plus 25, which is 9 plus 4 is 13 plus 25 is 38, so it is square root of 38. And now let's move up and plug everything here. So data equal cosine inverse of cosine inverse. So u dot v, we find that it's negative 11, and the magnitude of u is 3 times the magnitude of v, it's 38. So if you're using a calculator, just make sure what you want the answer in. If you want it in radian, it will be 2.21 radians. If they asking to find the angle in degrees, change the mode of your calculator to degrees, and it's gonna be 126.5 degrees. So this is the angle between these two given vectors u and v, using the formula I just showed you before. So I will pause here and continue the next video. Thank you for watching.